Okay guys, this is part 2 of section 2.5, exponent laws 2. Okay, and this is the last section that's found in this chapter. So make note of that in your notes. Keep your notes nice and neat and organized, and when you're ready, we'll move on. Okay, so a quick little review. I know we've done this a million times, but as you keep learning more and more exponent rules, it's easy to get them confused, which is why I keep reviewing the basics, so you keep everything straight. So remember when you've done these, our rule was if you're multiplying powers with the same base, you can add your exponents. So we keep our same base here, base of 5, and then it's 1 plus 4, or 5 to the 5. Oops. 5 to the 5. Okay, and when you're dividing, same bases, your exponent rule says you can keep your base, and you subtract your exponents. So 5 minus 3, that gives us 5 to the 2, or 5 squared. Okay, and you will see these basic exponent rules in today's practice work. They keep popping up as we add more and more rules onto the chapter. Okay, so that's a quick little review. Next, in the first part of this section, we talked about power of a power. So, right, power of a power. Okay, so the rule for that was you can multiply the exponents together. So if you had 2 to the power 3, all of this to the power 2, you multiply your exponents together to get 2 to the power 6. All right, and another quick review of your exponent rules. We also had power of a product, which you could deal with in 2 ways. So if you had 2 times 5, all of that to the power of 2, you can use the exponent rule and bring your power in, 2 to the power of 2 times 5 to the power of 2, and solve from there. 2 to the power of 2 is 4. 5 squared is 25. Multiply these together and get 100. Or you can use your order of operations. You can deal with your inside your brackets first. 2 times 5 is 10. Bring over your exponent. This equals 10 squared or 100. Both answers are the same, which is great. Either way works fine. A lot of people prefer this way. However, this is a good strategy to have in your back pocket. Sometimes you may have to use this to simplify some of your workings. Okay, with those 4 exponent rules in mind, I want you guys to pause the video. I want you to try these 2 simple little examples, and then we'll move on. Okay, so by now you should have these 2 attempted. This one over here, we have a power to a power, so we flick back to this rule where we can multiply the exponents. So 5 to the power of 3 to the power of 7 is the same as 5 to the power of 3 times 7, or 5 to the power of 21, which would be a very large number. So that's 5 times itself 21 times. Okay, this one here, I'm going to do the order of operations. So I'm going to do inside my brackets first. 8 times 4 is 32. And that's 32 to the power of 3. Okay, and I'm going to leave it like that. If you are asked to evaluate, that means you have to actually work your powers out. So this one here will be 5 to the power of 21, which is this number. You would have to write that out. And 32 to the power of 3 would be 32 to the power of 3 would be this number right here. So that's if you were asked to evaluate the expression. Alright, now moving on to some new things. Here's the last exponent rule that we're going to be working with. It's very simple. It follows the power of a product rule, but this time we're having power of a quotient. So pause the video, write out these notes, and when we come back, we'll discuss it. Okay, so a power like 12 over 6, all of it to the power of 2, or 12 over 6 squared, is called power of a quotient, because we have a quotient here. Quotient means divide. It's related to division, and that's what we have here, 12 divided by 6. Okay, so you can deal with this, the power of a quotient, in the following two ways. Same as power of a product, you can deal with it using the exponent rule. And the exponent rule says that you can bring your power into your numerator and bring your power into your denominator. Okay, so you would have 12 squared over 6 squared, which is what we have here. Then you can work it out. 12 squared equals, 12 times 12 is 144, and 6 squared equals 36. Then, to simplify this, 144 divided by 36 is actually a nice even number 4. Order of operations says that you can do what's in your bracket first. So 12 divided by 6 is 2. 2 squared equals 4. Again, a lot of students prefer order of operations because it looks a lot less messy. It looks a lot more simple. But again, this is a good tool to have in your back pocket for future problems. Okay, so if you're ready, we can move on. If you have any questions, please let me know. Okay, so examples. I want you to write this down. The first one you're going to write down in your book, but you're going to follow along with me. The second one, we're going to pause the video and you're going to give it a try by yourself. But I want both examples in your notes. Okay, so follow along. 2 over 5 to the power of 4. Now the first thing I check is, can I simplify what's in my brackets? In this case, I cannot. 2 over 5, 5 cannot go into 2. So I'm going to have to use my law of exponents, my exponent rule. So the exponent rule says I can bring this in to 2 to the power of 4. And whatever, I have to do that to my numerator, and I have to do that to my denominator. 5 to the power of 4. Okay, so 2 to the power of 4. 2 to the power of 4 is 16 over 5 to the power of 4 is 625. And then you can simplify this if you can. So I don't actually know off the top of my head how that can simplify. Divisible by, don't think it can be simplified. 625 divided by, no. Nope, so we're just going to leave it like that for now. Alright, I want you to make sure you have that written down, then I want you to give this one a try. Okay, by now you should have this one attempted. We're just going to go through it together. Can we simplify what's inside of our brackets first? No, so we're going to have 4 to the power of 3 using our exponent rule over 7 to the power of 3. So 4 to the power of 3, 4 to the power of 3, 64 over 7, there, 7 to the power of 3, 343. And again, you have to check and see if it can be simplified. I don't think it can. It may. So I'm going to check 2 of these on a graphing calculator. Just give me 1 second to pop up my graphing calculator. Okay, so I'm going to plug these in. I'm going to show you a quick little trick to how you can simplify them. So 16 divided by 625, I'm just doing this fraction here, equals, and to check and see if it can be simplified, we press Math, Enter, Enter, and it cannot be simplified. If it could, it would spit out the fraction that is in its lowest terms. Okay, so let's try this one over here. 64 divided by 343 equals Math, Enter, Enter. And that is the most simplified answer. Okay, so that's just a quick little trick for simplifying fractions. So back to our notes. We're going to try these now, and these are the last examples for today before I give you your practice work. So again, follow along with me for the first one, then pause the video and attempt the second one. So the first one, 25 over 5 to the power of 4. I can actually use the order of operations here, and that's what I'm going to do to make my life easier. So 25 divided by 5 is 5, and we bring down our exponent, 5 to the power of 4. Now we have a nice neat little power there. So clear 5 to the power of, where's my power of button? To the power of 4 equals 625. And then we're done. Okay, try this one on your own now. And when you're ready, press play, and we'll see if you get the right answer. Okay, by now you should have this one attempted. So 28 divided by 7 to the power of 3. We can simplify this with the order of operations first. 28 divided by 7 is 4. And then to the power of 3. And 4 to the power of 3 is 64. Double check that on the calculator. 4 to the power of 3, 64. Okay, so that's a quick little lesson there, finishing off your exponent laws. That is the last section in this chapter, so we do have a test coming up soon. Check with me for the dates of that. And this is a textbook work that goes along with this problem. It's page 84, and you have had practice work from page 84, but these are different questions here. These are questions related to the power of a quotient. Okay, so write these down in your book so that you know which ones you're going to do, and then attempt these. Good luck with it. Let me know if you have any questions.